Let me put the recording. Okay. So let's start the recording. And Brian has some question. I was reviewing the previous slides and noticed you use technique in Minitab called probability plot. Would you this work for most data set to identify normal distribution? Or would you use multiple? So normal distribution, you can check, normality of the data date based on the normality plot or distribution plot, and you can see in that, and we are going to look today also, Brian. So I will demonstrate today also that. Okay. So let me start basic concepts and why we use and all, and then we will do in mini tabs. So let me start my whiteboard, and from there we will learn. Okay, here we go. Can you see my whiteboard?
Yes.
Okay, perfect. So let's say, so regression means the meaning of regression is causal relationship. Cause and effect, you can say cause and effect basically. This is a very simple meaning. So what is the effect and due to what? So let's say this is effect and this is cause. If you increase the cause, what is going to be the output? Or you can say this is input and how input is going to affect outcome or output. So this is a very simple meaning of regression. And if you be plot the data, that graph between input and output, let's say this is the graph that we got. So this is y and this is x. This is 0. So if we plot this area, this part, right from this is called intercept. This is called intercept. And if you put 2 points on the line, any 2 points at any place on the line, let's say I'm putting here, you do the horizontal and vertical lines. Let's say this. So this is the difference in y. You can say this is a y difference means, and this is del difference, x difference. So if I want to know the slope, I can get the slope. Slope equal to difference in y divided by difference in x. So a simple regression is y equal to intercept plus slope and multiply by x. Means this is a cause and this is the effect. This is the effect. And if you make the model based on the data, and if you put the value of cause, you can get the result of effect. Or if you put the input, you get the output, provided you know the intercept, provided you know the slope of the data, or this graph. So this is a very simple thing, and many nowadays many places we use the regression. So this is simple regression. Simple regression means you have only one input, output is certainly one. Let's say a simple example. Income and spending. I want to know so first, let's say I collect the data of 30 of 35 students and their income and their spending. Higher is the income, more is the spending. So if I go and I do that, this line shows if you increase the income, you will also increase the spending. Okay, I want to see if I have income of certain amount, what would be my spending? So based on this data, or spending equal to, the model will be spending equal to this intercept. I can say this A plus this slope of this B, B, and I can go income. Now let's say based on this data, I got A value and I got V value. And if I put my income is 90,000, what is my spending? So this is simple regression. But if I do the multiple regression, it can be depend on multiple factors. Spending equal to A plus B income,
B plus
B or slope income plus C family size plus D some other factors, the trouble amount or trouble expenses and different other habits. So multiple regression equal to you have multiple independent factors or multiple independent variable. So more than one input, that is called multiple regression, where you have more than one independent variable. So first thing, in order to start regression, you need to design your idea what should be the outcome and what are the items or what are the factors on which outcome is depend. So if you understand this concept, let's start the basic statistics using Minitab, and let me explain over there. Is it clear to everyone? No, yes,
yes.
perfect. So now I share my uh, Minitab. So wait a minute. Can you see my screen?
Yes.
Okay, perfect. So this is the data that I got. So basically, this is the data related to Indian students. And if you know that if somebody wants to get into higher studies in USA, they need to have GRE or GMAT and the English score, what kind of university they want to get in, 4 star, 3 star, 2 star. They have to write the statement of purpose, why they want to get the admission into that university, letter of recommendation from ex colleague or ex boss or professors, GPA. So here in USA, we have a GPA based on 4 point scale. In India, we have 10 point scale. So GPA is here. Whether it's a research university or teaching university, let's say Eastern is a teaching university, we don't have research, PhD and other things like WSU or University of Washington and Washington State University. They are research university because they have doctorate program, they have large projects. So research. what is the chance of admission? So basically, chance of admission depends on all these factors. So this is outcome, this is by variable, and these are all x variables, or x1, x2, x3, x4, are all independent. So what I do, we are only learning one method. Best fit method we are learning, though there are other things that you will learn yourself, and we are just going to uh, do in homeworks and exam fit regression model. So this is the only option we need to check. So let's see. The chance of admission is the dependent variable, and independent variables are from here to here. And let's select here. Okay. And now do it here. Nothing else you have to do. So basically, if you can see this model here, oh, hope you can see. So chance of admission, this is the very first item is intercept, like we saw. This is slope of GRE. This is a slope of TOEFL. This is slope of university rating. This is a slope of statement of purpose. This is a slope of letter of recommendation. This is the model. We got the model. Now our question is that whether this model is valid or not. So first hypothesis comes, we have to make the hypothesis, and based on that, so let me show you here. Can you see my slide part?
Yes.
Okay, so slide, this is all the true coefficient are zero, means you can say null hypothesis says all these intercept and all these constants are zero. Null hypothesis says if all are zero means our model will be useless. So all the coefficients are zero. Alternative says at least one coefficient is non-zero. So at least one is non-zero. And I also explained, using this, just a minute. Can you see this? And this is right at the bottom of this. So basically I have made this screenshot, what we need to do in order to proceed here. So this is the PDF right at the bottom of the module. You can find this, but we are just going to. So null hypothesis, all coefficient are zero and alternative is non-zero. So let's look into the why we are saying if these are all zero means minus 1.76, this is zero, this is zero, means everything is zero, means there is no value of this model will be useless, but at least one will be non-zero, let's say statement of purpose. Then you will put some value here, you will get some value of chance of admission. So we are going to look whether these are useful or not. How we can check? Exact same principle that we applied, p value and alpha value. Now look, by default this is doing 95%, means alpha equal to 5%. By default we are doing this, and we can see this coefficient right here. Can you see this? So use your past knowledge, uh, the p value and alpha value. What do you predict here and what do you conclude here? So constant or intercept, p value is zero. What do you say? Useful or useless?
Usually,
No, this is useful
oh, sorry.
because,
Yeah, it is less than alpha.
yeah, because this is less than alpha. GRE, again, useful.
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 Exactly, this is also useful.
Yeah.
What about university rating?
Not useful.
Exactly. And a statement of purpose?
Not useful as well.
Exactly. And we will prove this later. And I will show you what is the useful and useless of these two things. And rest of the things are useful. So in this model is two items. One is a statement of purpose and what is inversity rating. These are useless predictor, means having this in the model or not having in the model does not affect much. And we will see after this. So if you see the p value based on that, which is useful or not useful. Now look into this. This is a model summary after that, whether how much change, this r is first you look into this is called standard error of estimate, or standard error of estimate. What is the meaning of this? This indicates that average average from the fit line. This is the prediction, or this is average deviation or average uh, distance from the best fit line. So basically that means how you can see how best is the model. Small is the value of s is better is the fit line. So this is about 0.059, which is you can say 0.06. So this is, and I can also demonstrate on whiteboard. This is r square. What is the meaning of r square? R square means the change in chance of admission. Chance of admission is explained 82% explained by these factor. So 82% chance of admission is due to these, whatever constant GRE, TOEFL, university rate,
Teaching.
all these 6 7 factors. So 82% chance of admission is due to these items. So this is the cause. This is the cause. So 80% chance of admission can be explained by these 6 7 factors. This is so basically this is the effect and these are the causes. So 82% effect is due to these causes. Is it making sense? So this is the meaning of
Yep.
R square. What is the adjusted R square? So this is called adjusted R square. This is always little bit lower than R square. So basically, if R square is 82.19, this is 81 point. This is always little bit lower than this. It means this is more purified value. More purified, like you have something like something, then you filter it and you get more purified results. Same thing. Why? Because it is extracting. You have two useless items in this model. One is SOP, one is university rating, which is filtering this, and this is better result. You have also some unusual observation. It is filtering from the model. Therefore adjusted R square is little bit lower, and it is, you can say, more filtered value. However, usually this R value is useful. R square, this is more or less, and it has further, but I never seen this value is used, and I have never come across this is being used in some calculation or interpretation. But R square adjusted, R square, and this. Now look into that. If I see if my overall model is useful or not. How I can see? Basically, I can see based on this is regression. Can you see this? This regression, overall regression, is useful or not? Now you tell me. This is a p-value.
Useful.
Exactly. Overall regression is useful, and which can be p-value. If p-value is more than alpha value, we can say overall regression is useless. Now again the same thing, same p value and university rating. So you can see now here I come back. What is the relationship between these coefficient standard error or coefficient t value? So coefficient, this, this, and this has the relationship. How we can calculate? So basically minus 12.23 and multiplied with this, you get this coefficient result. So let me show you on calculator. So you can see my calculator, 12.23 into 0.104 equal to, you get 1.276. Similarly, you can do for GRE 3.7, 3.7 multiplied with 3 times 0, 0.000502. Am I correct? Yes. You will get this number, 0.001859. And so 0.001855. So basically they have done something. So basically, so if you know two these numbers, means you know either two numbers, you can get the third number. Is it making sense? P value, this is VIF. It's called multicollinearity. How we check, multicollinearity means two variables are having exact same impact or exact same kind of behavior. Then they will show the same kind of prediction behavior in the model, and there is a reason of multicollinearity in the model. And researcher or people always avoid multicollinearity, and we check multicollinearity based on VIF. So if VIF is up to 2, no problem. Up to 5 is also no problem. But when you have VIF is more than this value, more than 10 or something, it is called multicollinearity. And we can also see here how we can check it. But here I would like to show you. So where's multicollinearity? Yeah, this is multicollinearity. Can you see my slide?
Yes.
So here, if VIF is 0, that means no variance inflation. Okay. If up to 2, you can say mild. 10, a strong variance inflation. And if it is more than 100 or 100. So basically, researcher or people, those who make, they would prefer up to 5 or 6, VIF value up to 5 to 6. So in our model, we don't observe multicollinearity. Severe multicollinearity we have not observed. You can clearly see no, everything is under 5. So no multicollinearity has been observed. Now, these are the, if you can see these are unusual values. Unusual means, these are deviated from the model. These are, so here it says 10th observation, 10th. Here chance of admission is only 45, where the other things are. So let's see 10th observation. So here you see 10th observation, here chance of admission, where is somewhere chance of admission is only 45, where this is this. So these observations, maybe somebody has made the data entry problem or data collection issue. So it is saying that maybe due to chance or maybe due to error, maybe due to some other things, these values, like whatever number are given, they are behaving unusual. So Either if you want better results, you go and correct or check with the people, those who have given this information, if this is correct, or you can remove from the model, or you can remove in order to get better results. So these are unusual observation. Now I think two questions. Uh, so is the process we are using exactly? So basically, Rini, you are going to develop some dependent variable and independent variable. You are going to have some data and you are going to check your validity of a model, whether your model is good to predict or not.
Thank you.
Yeah, most welcome, Doc. Just a minute, I have to. Using the calculator in Minitab to calculate p-value from t-value and degree of freedom is reliable. Calculator in Minitab to calculate p-value from t-value. Yeah, that is also exactly because the software is made for that. And Abhi, so I have to clarify question about the discussion for when we supposed to gather data in our field or our different predictor. So basically look into the, because this is, you can just ask somebody randomly. You can ask, and based on that you can design your experiment. You can design your experiment, or if you have less than 30, you can also, like, you just talk normally. What do you think? Let's say you ask to me, what is the chance of a layoff in the university, state university in US? And you can take my input on different, feedback on different variable. I can say on 1 to 5 or 1 to 7 or whatever. Uh, yeah, at least you should have sufficient independent variable to justify. Think about the hiring or layoff is not only depend on one factor. Layoff depends on multiple factor, industry demand, AI, and different other factors. So your experiment design, or this kind of practical design, has to have some logical reasoning, and some causal analysis. Based on that you can design factors, and you can collect the data, and you can run this model. Doesn't matter model is good or not.
So we don't necessarily need data to get our B values.
So certainly you need a data. How, first you need to make logical explanation. This is outcome, and these might be the inputs. These might be the independent variable. Therefore, this is outcome is coming. So let's talk about this in little bit, 5-10 minutes. Let me finish this and then I will talk about the discussion. Okay.
Okay, thanks.
Yeah. So I was explaining this part. So yeah, this is all. Now let's look into the, so basically I said, this is useful and useless thing. These are useful and this is, can you see my mini tab?
Yes.
Yes.
Okay. So what we need to do in Minitab, first we need to train the model to Minitab, and then only we can do the regression and you can use the predict. You can use this option only when you run fit regression model. So again, you need to go here, and then only this option will come when first you train Minitab the model. If I don't have this, let's say I just remove this and I go under stat basic regression. Oh, because already previously I run, so it is. But if you directly predict, it will not understand because you don't know. So let me run first model again. Regression, fit regression model, and okay, here we go. And now I go stat regression predict. Now let's take two scenario, one where the all items are exactly same, but we are going to use this one is maximum and one is minimum. So GRE, I'm just taking 337 for both student, 337. TOEFL score, I'm just taking 109, 109. Both are university rating. Here I am taking 4, here I am taking 1. Highest and lowest. Okay. A statement of purpose, one is taking 4.5, and here I'm taking 0 or 1, sorry. Means whatever you can write, letter of recommendation, exactly same 4.5, 4.5. GPA is 9, 9, and research, both are research and research. Let's see what is the impact on chance of admission. So here the first case where you have highest university rating and you have highest statement of purpose, you have chance of admission is about 84% or 85%. Okay. Now here when you have almost lowest value, means doesn't matter whatever university or lowest university you put, or you don't put the statement of purpose, or you can write anything in a statement of purpose, means you have least value of, and here you have almost 83%, 82 or 83. That means even if you forget a statement of purpose or filling the university rating, your admission is marginally or hardly impacting how much. uh, how much is here? 84, 85, and here is about 80, so about 2%. Is it making sense? That means these two items are not playing important role in the prediction. So this is the meaning of this. But so now here you have prediction interval, you have a confidence interval. So basically in few fill in the blanks I have asked to put the higher value prediction interval and confidence interval. So what is the predicted value and predicted value plus minus confidence interval? So this is uh, now let me tell you a few more things about this. So basically, if you see the error, are error normally distributed? So we are going to just see few other things and then I will explain uh, about the just a minute discussion part. So yeah, whiteboard. So basically in regression modeling, if you can see my whiteboard, can you see?
Yes.
Okay,
Yes.
let's say you have this, these are the observation, different observation. And when you put the regression line, this is best fit regression line. So basically these are the error, this is actual, this is ideal, but this is from the actual. This is the one, this is the one. So this is called error. Are these errors are normally distributed? How we can see? So we can go here and I again run here graph, sorry, regression, fit regression model, and here I stored the somewhere here.
We
So,
can't see your mini tab. Are you trying to show?
oh yeah, just a minute, sorry.
That's okay. Thank you.
Yeah, I was just share screen. So can you see now my mini tab?
Yes, thank you.
So here I go under statistics regression model, fit regression model. And now I store here we have the option to results, and here I can select, and here I can store the residual, standard residuals and all. I can, so this is a residual. I can store this, let's say, and this is like my residual. Plus minus means above the line is plus, below the line is minus. So this is my errors. I would like to check whether these errors are normally distributed. So I go under statistics, sorry, under graph, and this is the answer. Probability is graph and probability plot. And here I look into this, and here I can see the residual, and you can see. Now, the against the same hypothesis is here, and I also explained in the PDF. Look into this. Why this is not popping? Okay, here we have, see, can you see my PDF? So here null hypothesis is normal, alternative says not normal. So this is normal and not normal, and we can select based on p-value. So here in this slide, you can see p-value is higher than 0.05. So this is the normal case. But because you can see almost all the lines are within these, all the dots are within uh, these lines. But when you see here, what do you predict? What do you say? It's not normal. The errors are not normally distributed. The reason is that p-value is much less than 0.5%, 0.005. And you can clearly see this is normality and not normality. So this is the way to check whether it's normal or not normal, normally distributed or not normally distributed. So this is one thing. Now, other thing which is important in this, which is called Darwin-Watson. So errors are normally distributed or not. So normal probability plot can be done, which we just did to check. Now we will come over here whether, non-constant variation or constant variation. Here you can see the errors have constant variation and error have non-constant variation. We can clearly see using plot, and that I can just demonstrate. So if you can see, this is non-constant variation, because you can see funnel in or funnel out situation, which is non-constant. But apart from that, and here errors are autocorrelated or not autocorrelated, are non-autocorrelated or autocorrelated, and which is done using Darwin-Watson test, and which is usually done in the time series data. So null hypothesis errors are non-autocorrelated, errors are autocorrelated. So basically, this is less than 2 suggests positive and more than 2 suggests negative. So and DW value lies between 0 to 4. Though we don't need to use for our, but I'm just explaining based on this. So let's look into our Minitab, all these things. So we looked into the this part. Now let's look into other things. We did, I think, Darwin-Watson test also. Here, Darwin-Watson test value is coming this, which is less than 2. And now we go under here, assistance. We have assistance, and under assistance, look into the regression. And regression, multiple regression, the response variable is chance of admission. These are the rest of the items. I think 5 variables can be used here, not more than 5. So we are not using the statement of purpose. And okay, I think here. So you can see here, yeah, look into that. So what do you say, whether non-constant or constant variation? So basically I can see this is like a funnel in here. So basically this is another. So you can see this graph here, funnel in and funnel out. So here you can see funnel in is coming. So these are the few important things related to regression. So mostly questions are based on simple model, p-value, f-value. Overall regression is useful. What is the statistics for overall regression? For overall regression, this is the statistics. This is the for overall value. This is f value. F statistics is the overall regression. Useful is this in this case, but based on your data. So this is about regression. Now, please feel free to ask the question if you have. Now, let me show you about what is the discussion expectations. So let's say layoff, based on every one industry, let's say layoffs is the function of, can you see my whiteboard?
Yes.
Maybe AI, market recession, or market performance, or whatever you can say. Different other, issues can be there. That could be reason of layoff, or performance of the industry, performance of the business, um, consumer spending. Many factors can be there, ultimately resulting in the layoff, because if uh, business doesn't have the income or performance, how they can continue. So by equal to a plus bx1. So basically, first you start your thought process from your understanding what could be the reason of layoff. So bx1 plus cx2 plus keep going on. So 5 variable. Now getting the data. So layoff, you can say 5% layoff. This you can say, you can ask these questions from uh, your friend or anyone, or you can just read the forums, different forums, and based on the different online resources are available. For example, layoff.com, layoff.fyi. So look into that kind of thing, and you have five indicator and one dependent variable. Let's say layoff 0.05. This is 5%. Reason is that industry performance is reduced by 5%. So maybe 5%. Or you can say AI is impacting. You can take input 1 to 5 point scale, 1 to 7 point scale. how AI is impacting your industry. Let's say 1 to 7. Somebody is saying 4. Out of that, you can keep this data. And other end, you can make this, this data. So basically, you are conducting an experiment to check your idea whether your thinking is correct. Maybe at the end of the result, you say, based on a data, my model is not valid, is not proved. That's fine. If but actually you understand the process. So this is what is expected in the discussion. Is it clear to everyone?
So what you're saying is we're going to pick some factors that we think will impact the layoff rates for a particular industry of our choice, and then
Yes.
we can ask people on a scale of 1 to 7, how impactful do you think that these factors are on the layoffs, and then we'll collect their ratings and put it all into a spreadsheet to then do multiple regression on?
Yes.
Okay.
Yes, that's exactly. So yeah, so basically, like on a tea, you are talking with your friend. You don't need to reveal anyone identity just for your experiment. Different opinion, different understanding, and you are running your experiment, and you are getting whether your experiment based on opinion is correct or not.
About
The-
10 people should be plenty.
I mean, so basically, the rule, 30, and when we can consider the normality more than what should be the. But if you don't get, okay, but 10 people will not get the better model. So have enough, but I will not say at the end of the day, okay, you have not done. Try to collect as many as.
So the closer to 30 people that we can ask, the better, and you would like at least 5 factors looked at?
Yeah, at least 5 factors. Think about, if you see, okay, 4 factors are most important, okay, I will consider 4. Because anything layoff is not only 1 or 2 factors nowadays. Think about what are the different reasons happening. And I have shared this website, layoffs dot, and that is only demonstrating the layoffs in the tech industry. Different other industry across the world, not only in USA. I'm telling you, I have done the research in India, and I have done in Brazil and other parts. It's everywhere in the world. It is not only that US economy is impacting, it's happening in USA. So basically something bigger is happening under the that we would like to see, we don't know. So think from your understanding and just look into this lays of .fyi. I think this is the, if I write the correct website without a spelling mistake. Look into this website and see, or let me see if I can place here. Uh, so, and these lays of FYI. So this is the website, I think. Yes, this is only tech industry. And every day, this is yesterday, Skybox Securities. Uh, So every day they record, and they have the people means they have the spreadsheet who are the people fired from the job or laid off from the job, which you can see in different sorry, um, different spreadsheet here. So if I look into this, they have also shared somewhere the spreadsheet of each company, like in Google or Meta, or they have shared the complete 12,000 people. So just for your thought, checking your process, checking your understanding, and see if whatever number you can get, that would be perfect at the end of the day. Because there are many reasons just only straightforward saying one or two reasons are there for layoff. Many reasons are there. So this is the happening. Am I able to answer your question?
So the data we're putting into Minitab is the ratings that people are giving us for how important they think the different factors are.
Yes, you can put the
Okay,
rating. Yeah, you can take the
that makes
opinion.
sense.
Yeah. And you can always reach me. You can always show me your work before submitting.
Where does Y come from then?
What you said? Why?
Yeah, what would Y be then in the data sets if we,
Okay, so 5% layoff, 10% layoff. So basically think what do you think in your industry, what would be the what percent of layoff will be there? Certain they will not say 100%, they can say 5% layoff is there. Maybe 10% layoff will be there. So you can put that number by.
Can I ask a clarifying question? So, for example, I plan to do some of the industry for healthcare. That's what I work in. So, would my why be like I anticipate 20% of the layoffs to be due to AI?
So not only AI, but there may be other things like, we are the Kaiser, we have our medical plan with Kaiser, and we see a lot of changes are happening from last 2, 3 years. It is not only AI. There are other pressures happening with the, in a healthcare sector. So not only AI. So you have to first design what are the, what is the overall layoff is possible in healthcare industry. So somebody say 5%, 10%, 20%. Then what do you think? What is the AI? So AI 1 to 7 point. Okay, AI is the one. Then economic performance or economic situation. This is another thing. Then there could be third, lack of doctors or healthcare professional not available or something, or their demand or their salary expectations are high. So many things, many factors are there. Only AI is not the, all only AI is not the culprit. There are many other factors happening.
So
Is
the
it?
first question we're asking these people is what percent of layoffs do you think are going to be in this field?
Yes.
And then we ask them all our different
Yeah.
predictors and how they feel that's going to affect that number.
Exactly. Exactly.
Okay.
Yeah. So basically, first you design. Okay, these could be the reasons, these could be the factors through which the layoff. Some industry may not have, layoff also, but largely I see across the world, almost every industry is having a difficult situation as of now. Not only as of now, last 2, 3 years, jobs are not available. They are willing to do more work with less people in every industry. Like, I'm in education, I'm in academics, and I can simply tell, like, when I joined 6, 7 years ago in the same department, School of Business in Eastern, we have 60 plus people. Now we are 25 in 6, 7, 8 years. And not only here, may all the universities across the world. This is not I'm telling Eastern because I'm here in Eastern, so I tell you this. But when I see the entire world, I speak to my friends in different academic institute, different part of the world like Brazil, India, and other. They say the same thing is happening, and nobody knows the real reason. Students are not turning. Biggest reason for us, students are not turning, or students are not. Uh, so can we just use raw data like percent chance, or it's required to use the survey for? So you Matthews, you can have the data. You can share with me what you are doing, and I can quickly give you the feedback. So basically, have one outcome variable design in the way, not only layoff. If you think that you can come up with some different experiment, okay, you can choose to do that. you can have one dependent variable and five independent variable, and if you have the data, you just run and make your decision and make your discussion. So I won't have any problem. If you are not able to do on layoffs, you can do on different other experiment or different other area. Most welcome.
Is it going to be okay, like if one of our friends rates each factor a 7 of importance, or are they only allowed to use one number once, like it's a ranking?
So so basically, when you take the opinion on Likert scale, 1 to 7, 1 to 5. So 1 to 7 is good scale because you can have proper median or proper peak. So if I ask you, how do you like this course? 1 to 7 point scale. Maybe you put 4, you will put 5 or 6. So it's a Likert scale. You give them the choice to choose. And
Yeah, I understand the Likert scale, but I was just asking, are they allowed to say for factor one they rate it a 7, and then for factor two they rate it a 7? For that, that's going to be okay that each
yeah,
factor is rated a 7 to
yeah,
them?
yeah, that's
Okay.
fine. If they feel that is 7, that's their opinion. We count them and we do the model. Perfect. That's their opinion.
Appreciate you clarifying that.
Most welcome. Can I use Excel since I have failed to download many? I tried to IT department of Jen. Certainly, Excel does exactly the same way, but you have to do add in option with data analytics option. To do that, you can do no problem. And do you want me to help you after the class to download on your computer? Yeah, I mean after the class is over, I can show you on your screen to do that.
Yes, please.
Okay. Okay. Any other question? So please be, there. Let see
I,
if everyone. Yeah,
oh, sorry, I have one. I know that you said this, and I just wanted to make sure I heard you correctly. If layoffs end up not working, we could pick another topic for our
e-
data as long as we're doing the multiple regression for you.
exactly.
Okay.
You can choose any experiment. You can design any experiment that you feel you are more comfortable, you have the access of data, or you have something that you can put. So my purpose is that you are able to design any experiment related to multiple regression. And since the layoffs is current, this is a very hot topic as of now, and therefore I want uh, you to just do the experiment related to the current topic. That's it.
Cool, thank you.
Most welcome. Okay, so I'm just
So,
yeah, go ahead.
so in case of, I mean, like when we were looking at uh, when we were looking at the the mini tab, we saw the outliers were, I mean, like so there were outliers which were so can we so what I mean, like in normal cases we should be omitting them, and um, then we can re-experiment those, right? So now,
So
sorry,
basically, Atul, those outliers or those unusual observations are demonstrating you need to double check whether these entries are correctly
data.
done, or the people have, or there is error in data. If these are correct, or you say this is unusual things, some people they scored this much chance of admission. Okay, fine, include them. But that gives you the alarm that probably here could be the mistakes because they are going their error is very high from the fit line. So so usually you have a chance to look into your data one more time. Oh, but if you see, okay, no, this is totally correct and it is coming from the, ogre. Okay, fine.
And in case of so we like at least with adjusted R squares, like since it is dependent on the num sample size or the number of columns or variables that we select. So now in earlier case where we saw that the two attributes were unuseful, so I mean they were not useful in that case. I mean like so we can go ahead and exclude them and predict them, right? Like we can say like we tried these two columns and they were not contributing, and so we omitted those or something like that.
So basically, when actually you are doing, for example, two cases in our data in our model, a statement of purpose and university rating. Our university rating are not useful predictor. So you can conclude when you make prediction, or when you talk about the model, you can simply say these two factors are not making bigger contributions. So if you in your decision, you can suggest to student, okay, don't put your emphasis of writing a statement of purpose, don't put your 5 days just for framing, reframing, rephrasing your statement of purpose, don't focus too much on selecting the university, because they are not going to play a crucial role in your admission. So basically, from decision point of view, you can, let's say, in your sales, let's say this is a case of sales. So your sales is not, sales performance is two such kind of factors, like this. Okay, you can direct your team, okay, dear team, don't emphasize on these two, because whatever impact or whatever performance you put in these two areas, our sales is remain almost same. So just divert your resources from there to somewhere where you can influence your sales. Is it making sense?
Yeah.
Okay, so yeah, so Jen, I'm just stopping the recording, and I can help you to download
Okay.
your 1 minute. Just a minute. Thank you, everyone. Have a wonderful evening, wonderful night.
Thank you.
So,
Thank you.
Rennie, if I
Thank
decide to
you.
do number of layoffs, would be my table look like a table you? Yes, yes, Rennie, it's like same. It's like similar kind of thing. Yeah, just a minute. And more, stop recording.